Today, we are stepping into something that feels a little bit like The Matrix, but, and I mean this with all due respect to Keanu, with a much better wardrobe department.
Way. That's a good way to put it.
We are looking at a project called Shankpit, and specifically, a massive update labeled Phase 525, the Digital Tailor.
It's a fascinating title, isn't it? The Digital Tailor. It implies a level of craftsmanship and intentionality you don't usually associate with raw C code.
Right.
Usually when we look at code, it's about efficiency or logic. This is about style.
Exactly. And usually when we look at updates for games or simulations, we're talking about, I don't know, netcode optimization, server tick rate, something like that. But this is purely about the drip.
In a way, yes. But if we look at the source material we have today, which is literally the raw Python script that injects the C code for the game, it's actually a masterclass in how you build an identity out of pure mathematics.
We're not even looking at concept art.
No 3D renders, no JPEGs. We are looking at the instructions that build the world from nothing.
Okay, so let's set the scene for everyone listening. Before this update, the players in this world, the Shankpit, were what?
They were placeholders, generic red boxes.
Just hitboxes.
Exactly, just hitboxes moving around a screen. Functional? Sure, they did the job of representing a player. But they were soulless. It was, programmer art.
And Phase 525 changes everything.
Okay.
We aren't just getting a texture update, we are seeing the birth of a faction called the Neon Ronin.
And that name is important.
It is. And the developer's note right at the top of the source code says it all. The Neon Ronin faction isn't just a UI layer, it needs to physically exist in the world.
That distinction is key. Physically exist.
Yeah.
They didn't just paste a picture of a cool jacket onto a box. They wrote code to construct the jacket, polygon by polygon.
It has volume.
It occupies space.
Okay, let's unpack this fit, because frankly, it sounds better than what I have in my closet right now. We are moving from a red box to something called the Ronin shell. What are we looking at here?
So diving into the function draw no shell in the code,
Yeah.
we see the geometry being defined. The developer explicitly wants a low-poly representation of the Phase 521 merch collection.
Wait, hold on. Merch collection, so this is self-referential.
It seems so. It treats the in-game gear as if it were a high-end fashion drop.
Mm-hmm.
The code defines a jacket that is matte black.
Okay.
The RGB values are 0.1F, so 0.1F, 0.1F.
Can we pause on the math for a second? Because I think this is interesting. Usually, people think of color as, what, 0 to 255?
Right. In web design or Photoshop, you use 0 to 255. But in OpenGL, which is the graphics language being used here, colors are floating point numbers between 0.0 and 1.0.
So 1.0 is full brightness.
And 0.0 is pure black. So when the code says 0.1F, it means 10% brightness.
So it's not a black hole, it's not an absence of light.
Exactly. If it were 0.0, it would just look like a void. By setting it to 0.1, you get this very deep, soft, sort of charcoal black. It absorbs light, but it still has presence. It feels like a high-quality fabric.
And the silhouette is what's interesting to me. It's described in the comments as having broader shoulders and a cropped waistline.
Cropped. So we're talking high-fashion streetwear here.
Very much so. It's that boxy, oversized top half that tapers down. It's an inverted triangle. But here is where it gets really interesting and where the tailor part comes in.
Oh, the lining?
Yes. The code explicitly mentions and actually renders a red satin lining visible at the hem.
I saw that. GL color 3F. 0.6F, 0.0F, 0.0F. A deep blood red.
Precisely. And the way they do it is by drawing a specific a flat rectangle at the bottom interior of the jacket geometry.
But think about the effort involved there. Why would you code the inside of a jacket?
That's the question, right? Most players might just see a flash of red when the character jumps or spins. But the code dedicates specific lines to ensure that lining is there. It suggests luxury. It suggests that this isn't just combat gear, it's a statement piece.
It's the difference between buying a uniform and buying a designer piece. The lining is for you. It adds weight and reality to the object. If you spin around and see that flash of blood red against the matte black, it breaks up the visual monotony.
It's a pop of color.
And it serves a real design purpose.
Okay, so we've got the cropped matte black jacket with the expensive lining. What about the rest of the outfit? You can't just wear that with anything.
You certainly can't. You need the right proportions. The source code defines tech cargo pants. The color is a charcoal 0.15F, 0.15F, 0.18F.
0.18F on the blue channel.
Exactly. Good catch. It's slightly lighter and bluer than the jacket.
Why do that?
Well, if they made the pants the exact same black as the jacket, the character would look like a silhouette blob. By shifting the tone just a tiny bit toward a cool blue, you create visual separation. You can see where the jacket ends and the pants begin.
Nice. Layering tones. And the shape.
The geometry notes specifically mention wider leg geometry to simulate a baggy streetwear silhouette.
I love that. In the code, they are literally stretching the width of the box that represents the legs to make it look like baggy fabric.
It's a clever use of primitives. The function drawbox is just creating a cube. But by scaling that cube, making it wider on the X and Z axis but keeping the Y axis proportionate, you trick the eye into seeing heavy draped fabric rather than a rigid robot leg.
So baggy pants are just wider math.
Essentially, yes. Baggy pants are just a larger scaling variable, but it completely changes the read of the character. They don't look like a soldier, they look like a runner or a street samurai.
So we have this baggy techwear vibe, but we have to talk about the face, or I guess the lack of one, the storm mask.
The face of the faction. Yeah, this is handled in the draw storm mask function. It starts with a base black head block, but then they attach a dark gray front mask plate.
And looking at the code, this isn't just a flat texture painted on a cube. They are pushing and popping matrices to offset these shapes, right?
Correct. We see GL push matrix and GL translate derf. They are physically moving the drawing cursor in 3D space to place the mask plate slightly in front of the head block.
Yeah.
It creates actual depth.
And then the signature detail.
The vents.
The cyan vents.
Yeah, the code sets the color to pure cyan 0.0F, 1.0F, 1.0F. That is maxed out green and blue. It's electric. And they place these vents specifically on the cheeks of the mask.
It's giving me very cyberpunk anime vibes, but there's a note in the source description about a broken horn silhouette that really caught my imagination.
Yes, the source mentions an Oni mask influence with a broken horn. Now think about what that implies. An Oni is a Japanese demon. A Ronin is a masterless samurai. A broken horn, that implies a story.
It implies a fight they didn't quite win.
Or a badge of honor from a past life.
Right.
Exactly. While the primitive code we see focuses heavily on drawing the vents and the plate, that silhouette implies an asymmetry. And technically, asymmetry is annoying to code. Oh, absolutely. It is much easier to just say, draw the left side, and flip it and draw the right side. To deliberately code a broken horn means writing specific instructions to make something look damaged.
It's high-effort aesthetics.
It builds lore without writing a single word of dialogue.
It's storytelling through geometry. But there's something else about the way the character moves that caught my eye. The draw player third function.
Ah, yes. The separation of church and state.
Yeah.
Or rather, head and body.
Right. Because usually in simple games, or at least in the prototypes I've seen, if you look up, the whole character just tilts back like a plank of wood.
The dreaded plank effect. It looks ridiculous. It breaks the immersion immediately because humans don't move like that.
So what does this code do?
What this code does is separate the pitch, that's the looking up and down motion, from the body. The body follows the yaw, which is strictly rotation left and right, but the head block is in its own matrix push.
So the head can look up at the sky or down at the ground while the body stays planted.
Exactly. The code translates to the neck height. GL translate, 0, 2.3 FE row, and then applies the pitch rotation only to the mask and head. Makes the character feel alert. It gives them a neck.
It's such a small technical thing, but it changes the vibe entirely. Instead of a stiff box, you have a tactical operator scanning the environment.
It makes the Neon Ronin feel competent.
Competence is the right word.
It makes them feel like they belong in the space. And speaking of the space, the digital tailor didn't just dress the players. It dressed the world.
That's true. The source code has a whole section on lighting and atmosphere. We aren't in a white void anymore.
No. We are in a fog. The function setup lighting fog enables GOFOJ, and the color they chose is very specific, 0.05.0.1F.
Which is, what? Like a dark purple?
A very deep, almost midnight indigo. It's dark, moody, and synthwave. It limits visibility just enough to make those cyan vents on the masks pop.
So you have the charcoal and black characters hidden in the indigo fog, and then bam, bright cyan lights.
It's high contrast. It's classic visual design. You guide the player's eye with contrast. But the floor is what really sells the simulation aspect for me.
The cybergrid.
Yes. And what fascinates me here is the function generates cybergrid. It's procedural.
Meaning they don't load an image file, like a floor.jpg or something?
Correct. There is no image file. The code runs a loop, a 64 by 64 loop. It checks the coordinates of every single tile.
And what is it checking for?
It checks the edges. The code says that the pixel is on the edge -2 or Y2, paint it magenta.
So 255, 0, 255.
Right. And if it's in the middle, paint it a dark, dark purple. 10, 5, 20.
So it generates this glowing grid pattern on the fly, magenta lines on a dark void background.
It screams simulation.
Yeah.
It reminds the player that this is a digital space. It fits perfectly with the neon Ronin aesthetic. You have the charcoal and black streetwear against this glowing magenta and purple world.
It's a very specific color palette: cyan, magenta, indigo, black. It sounds incredible. It sounds like a music video, but it also sounds intense. There's a function here called apply screen shake that seems pretty aggressive.
This is the feel of the game. This is what game designers call juice. You know, you can have great graphics, but if shooting a weapon feels like clicking a mouse on a spreadsheet, it's boring.
Right, you want that kick. You want to feel the power.
The code here adds a visceral kick. When you shoot, provided your cooldowns are ready, it sets screen shake to 5.0.
It's 5.0 a lot.
In terms of screen rotation, yes, it's a significant jerk. Then, every frame, OI screen shake takes that value and randomly rotates the camera view using glow rotative.
It literally grabs the player's head and shakes it.
Physically rotates the camera matrix.
Yeah.
It creates a chaotic, jarring effect that simulates recoil impact. It bridges the gap between the code and the player's inner ear. You feel the shot.
I love that. It's not just I shot, it's boom. And I noticed the code ties this to the crosshairs too, right?
Oh, absolutely. The draw HUD function takes the player's recoil anim variable and expands the crosshair lines based on it. It's simple math recoil, 20.0F. But it tells the player, you are losing control. Stop shooting.
It visualizes the inaccuracy.
Exactly. It's intuitive. You don't need a tutorial to tell you that a wide crosshair means bad aim. The aesthetics teach you the mechanics.
Speaking of mechanics and teaching, let's talk about the HUD, the heads-up display. Because Phase 525 didn't just update the 3D world, it updated the branding.
This is where the Neon Ronin feel like a real organization. The code draws a string of text at the bottom. Shankpit Storm DV.
Storm Div. Storm Division.
Likely. It implies that these Neon Ronin are part of a specific unit, the Storm Division, and they have a logo, the Dryon Insignia function.
How do you draw a logo with code? I mean, usually you just load a transparent PNG file.
Not here. They are drawing it with trigonometry. The code uses a loop 4 int I0, I180, I plus 20, using cosine and sine to draw a semicircle representing helmet. Then it draws sharp lines for the jaw.
That is dedication. They are calculating the curves of the logo every single frame.
It keeps it infinitely crisp. No matter how big your screen is, that math holds up. But the kicker is the cyan crack.
The crack.
There is a specific line strip drawn in cyan, that same 0.0F, 1.0F, 1.0F that zigzags through the helmet. It visually reinforces that broken horn or battle damage motif we talked about earlier.
That is so cool. It's a logo defined by a math, branded onto the screen, tying back to the face mask of the character. It's a consistent visual language.
And don't forget the storm charges.
Right, the chevrons.
The function draws storm chevrons. It draws 5 chevrons, those V-shapes, stacked on the screen. This is where the UI is purely functional.
And they change color, right?
Yes. If a charge is active, it's bright red, 1.0F, 0.2F, 0.2F. If it's empty, it's a dark, dull red. And when you have charges, the screen literally screams storm active in text.
So the game is yelling at you that you're powered up.
It creates a sense of urgency. The storm isn't just a name, it's a mechanic you have to manage. The UI isn't just decoration, it's your dashboard.
Now, I want to step back and look at the digital tailor concept again. We've talked about the jacket, the pants, the mask. But technically, how is this working? Because the expert notes mention matrix pushes and pops. To the uninitiated, that sounds like a dance move.
It does sound like a dance move, doesn't it? In OpenGL, which is the system running under the hood here, the matrix is basically the coordinate system. It defines where 0 is right now.
Okay, so 0 is the center of the world.
Usually. But when you want to draw a hand attached to an arm, attached to a body, you need to move 0.
I see.
When you push a matrix, you save your current spot. You say, okay, put a pin here. Then you can move, rotate, and scale to draw a specific part, say the left sleeve. And you pop the matrix and you snap back to the pin you placed, ready to draw the right sleeve.
So it's like holding your finger on a spot on a map, exploring a side road, and then jumping back to your finger instantly.
That's a great analogy.
Yeah.